joining us today for another amazing show. We have a terrific guest for you today. Today, we are talking about reshaping access to orbit by decreasing cost and complexity using modular satellite and nanosatellites, actually. Welcome to the Tech and Space Leaders Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Paul Anderson. He is the founder and CEO of Blackwing Space. Welcome to the show, Paul.
Yeah, thanks so much, Lisa. It's great to be here on the show.
Absolutely. Maybe you can start by giving us a little bit of background on yourself and Blackwing Space.
Yeah, sounds great. So I've been in the space industry for over 15 years now, and I've watched the ebb and flow of moving from Space 1.0, government bespoke programs with large budgets and long lead times, into Space 2.0, where we are now with dual-use commercial companies fielding new technologies for commercial and government applications. And this inflection point where we're at now, moving into Space 3.0. So I started my career at the Aerospace Corporation, working national security space, spent some time with Vox Space and Virgin Orbit, launching space test program CubeSats up to low Earth orbit, helped TrustPoint launch its first few commercial GPS alternatives, broadcasting navigation signals in C-band at low Earth orbit altitudes, and then did some time as well at Tyche Research Group and Turian Space Corporation, working on high-fidelity astrodynamic software. So over my career, I've worked on space segment, I've worked ground segment, I've worked launch, I've worked the user side of user equipment, and putting that enterprise view together planted the seeds for what would become Blackwing Space. What we're doing now is building for the Space 3.0 infrastructure, where we see Space 3.0 as commercially diversified with brand new applications, kind of like the beginning of the internet, that are going to be hosted on space infrastructure. And we see an amazing market opportunity for lowering the cost and the complexity of accessing space with commercial modular nanosatellites that can be mass manufactured at scale, at low cost, because we are vertically integrated and leveraging those economies of scale. And it's such an exciting time, to serve both our commercial customers who have a need for, low friction, affordable access to space, and then also the dual-use government applications around proliferated architectures and swarm behavior, even orbital defense, using these small modular satellites. So it's a very exciting time, and happy to share more about what we're building at Blackwing Space during our time here together.
Absolutely. So let's dig into that a little bit deeper. When you think about Space 3.0, what role is Blackwing Space playing in that commercialization shift?
Well, we see our satellites as true commodity items, and this is the shift that needs to happen, right? Buying a spacecraft today for your, payload demonstration or fielding your initial operational capability of a service or product, it's still too bespoke. It's too one-off. And the analogy I like to use is if we tried to buy a car today, as if you were buying a satellite today, it would be this very, very lengthy 18 to 24 month process where you are signing NDAs, you are specifying all of your requirements from the ground up, and then you're getting a custom one-off satellite tailored to you, right? If we approach that with buying a car or buying a laptop computer, right, we would never have a commercially viable product. And so we want to make our satellites very easy to buy and with a user experience that is similar to buying a MacBook Pro or buying a car, right? And that user experience looks like you have a base model with known specifications and transparent pricing. You can layer on optional upgrades. In our case, that could be deployable solar panels, it could be extra battery capacity, crosslinks, propulsion, etc. And each of those upgrades has a known price increase as well. And so we're providing the consumer a menu of options for their space platform that they can go off and do their mission with, either as providing the platform only or Blackwing delivering the full end-to-end mission. So that's the first point is we want to commoditize our satellite platforms to make it really easy for people to develop hardware to them and for people to be able to purchase them online in the e-commerce era that we live in.
Wow, amazing. This is a really different approach from the traditional approach to building satellites. What are some of the most common technical and logistical bottlenecks that are run into using that traditional approach?
Yeah. So one of the big things, a lot of companies or these organizations that want to deploy new technology, they want to stay laser focused on their technology. Not just these companies, but their investors as well want to see them focused on what they are doing. But fielding an entire space mission is quite a complex, timely and expensive process, requiring coordination with regulators, say on FCC, ITU, NOAA, these organizations that control spectrum and imagery, through engagement with the launch integration world, securing a spot on a commercial rideshare vehicle, which is tightening up these days, as we know, and then integrating with ground station providers and dealing with all the tiny details of how do you command and control and operate a spacecraft. So we want to take care of all that complexity and provide that as a service to our customers. I would say 80% of our customers today want to focus on their technology and they don't want to get bogged down with the full mission delivery. And so in addition to Blackwing Space providing our modular platforms to make it very easy for these teams to deploy their payloads using our platforms, we can take care of the entire mission as well. We have strategic partnerships in launch and ground segment integration to make it very, very straightforward for these teams to access orbit on timelines and at price points that have never been seen before. And we think that's extremely exciting. It's going to open up an entirely new market and world of applications for Space 3.0.
Wow. Okay. So, I mean, I think you're kind of talking about some of the main friction points, that are run into in these types of missions. What are some of those friction points that this approach is going to eliminate?
Yeah, well, one of the first ones we wanted to tackle right off the bat, in my experience in my career, I've seen how to build a satellite well, how not to build it well, how to cause lots of problems for yourselves when you make design decisions, and then later on in the mission, it makes the launch integration more challenging, it increases the burden of paperwork, it puts regulatory licensing at question, right? And so we wanted to greatly simplify that. And one of the things we did right off the bat, using the approach that is seen in other places in the tech world, is the concept of open standards. And this is all over the software world, cloud infrastructure. We see it in the drone industry now as well. And if you look at the market right now, most satellite manufacturers out there today will ask you a laundry list of questions. What do you need for your payload so we can build a bespoke one-off design? And that one-off design carries a lot of cost and technical rigor and challenge associated with it. And that's a pain point a lot of teams get very frustrated with. They buy a bus, it's very expensive because it's custom, with custom components and new interface boards that have never been tested before. And then when schedule is crunched, they run into integration issues. And so at Blackwing Space, we said, let's start with an open source payload interface specification. So our payload teams are not starting from scratch. They have a sandbox, they have a template to work with. And you might see if you follow our LinkedIn page or simply go on our website, we've published this all online. What does our payload interface look like for the various classes of vehicles that we offer? This is our smallest, this is we have a bird-themed company. This is our Dodo board. It's meant not for flight, similar to the dodo. But we provide all this information and this data to payload teams that here's our standard module for our 1U XL Sparrow platform. And as long as these payload teams implement this form factor, right, and this housing with these mechanical interface points, we provide CAD files, we provide PCB design files, and we simply enforce that they provide this single connector here that provides the power and the digital signals into their payload hardware. But the rest of the board, the payload teams can do whatever they want with. And so people are developing GPUs for edge compute in space, tiny transceivers for Internet of Things or RF intelligence in space, all sorts of interesting, even lab-on-chip experiments that can fit with this form factor. So we wanted to remove that friction point by equipping the payload teams early on with, here is your standard form factor, and similar to Priority Mail, if it fits, it ships. And so we wanted to flip that equation around, and instead of asking you what your requirements are, we tell you what your interface requirements are, and if you build to that specification, you can fly for Ks instead of Ms.
This is really fascinating. Just to give our audience perspective on this, because not everyone knows what a nanosatellite is, can you define what a nanosatellite is?
Yeah, that's a great question. So there's a parlance there of small satellite, but a small satellite can often mean something as large as a washing machine, right? Which could be small compared to your traditional legacy spacecraft of many decades ago. When I say nanosatellite, we're beginning with the CubeSat form factor, one that a lot of the American industry has moved away from for a variety of reasons, but there is a drive to serve the U.S. government with exquisite capability that can only fit on really large platforms. But we've seen all through the past few decades a lot of amazing potential with the CubeSat form factor. And so just to walk you through it right here, this would be a little 3D model of a 1U CubeSat. It's simply a 10 by 10 by 10 centimeter cube as the standard, not to be confused with the U's for server racks that you hear in the orbital data center conversations. But I can take this, and this becomes this modular mini server rack for space, and we can pack this end-to-end with capability. Now, there's nothing new about the CubeSat form factor. This has been around for decades. This is compatible with every launch vehicle that has flown and probably ever will fly in the future, because it is like a little shipping container for space. And so this is the size of our smallest platform. The one that we are launching later this year in October is a 1.5U, so it's just a little bit bigger. But I love that the entire size of our satellite sits in the palm of your hand, right? And this carries a lot of implications, right? This is lower cost. There's less material. It's a lot easier to handle. I don't need a 2-ton crane to pick up my satellite and haul it around an expensive integration and test facility, right? We can even buy a seat for this on an airplane to bring it to the integration facility if we needed to. So there's a lot of rich benefits here. And over the last 5 to 10 years, Moore's law and the miniaturization of microelectronics has allowed us to pack more and more exquisite capability into these really small form factors. And so these aren't just educational grade missions anymore. This is next generation commercial capability in a small form factor that we can manufacture at scale. We can deploy at scale. We can, as I've heard another company say recently, begin the dronification of space.
Oh my gosh. What limitations, though, does the size put kind of those running missions under? Are there certain types of missions that this is just not an appropriate form factor for?
Right, and there are. We run up against physics with things like optics, for example. To get a really high resolution image with a good ground sample distance, we simply need a large optic, right? We can do, smaller missions such as, with these. Perhaps we can get close to another object and do in-space imaging with these as well. But there are fundamental limitations to some of the technologies. Now, that being said, there's a whole host of other applications that fit extremely well into these form factors. Edge compute is one example. RF sensing and intelligence. We don't need a very, very large radio. We can use a tiny software-defined radio that fits in this form factor with a small antenna that we can integrate on the exterior of the spacecraft, and then purchase, integrate, and launch 500-600 of those to provide global situational awareness. That is one of many applications that simply doesn't need a big satellite to do that. And so the big satellites, there's a lot of discussion around orbital data centers, around government missions, missile tracking, secure communications. But there's a whole host of other applications that are not being addressed in today's market, and this is the gap that Blackwing Space is filling.
Amazing. So what are some of those other applications? You gave a couple of examples there. Are there others that you'd like to highlight?
Yeah, there are others. This is what's so amazing about Space 3.0. If we think about the recent SpaceX IPO as being, say, the beginning of the internet, as many institutional investors are using that analogy, we can think about all of the downstream applications that are going to come from these satellites. And think as well about the parallel of what has happened in the drone industry. I just mentioned that word dronification, right? But drones over the past few years, right, have become smaller and more capable. They become fully commoditized and at price points that you can go on Amazon, buy a drone, it shows up a few days later, and you take it out of the box and you fly it. And my question is, why can't the experience of buying a satellite be exactly like that? Because if we can enable that type of commoditization, right, we can unleash an entire new generation of applications. In the same way that military drones did not give rise to drones washing windows of high-rise buildings. Those types of drones did not give rise to first-person view drone racing, right? It was only when these drones became truly commercial, low cost, and affordable, right, accessible to the general public, that we saw all these amazing applications take off. And so I'll tell you, Lisa, one that I think is really exciting is orbital racing. Very, very interesting application of racing around the Earth, racing from the Earth to the Moon, and there is a role for both large and small satellites in that. And this is something that never would have been possible 5 to 10 years ago. But as we think about access to space, commercialization of the technology, and broader public interest driven by the SpaceX IPO and the Artemis missions and all these great things that have happened that draw the public interest to space upward, we're going to see a lot of really interesting applications take hold. And I cannot wait to see what the next generation of builders is going to do with something this big.
Wow, that brings up a whole other conversation about orbital debris and things like that, but
Sure.
I don't think we'll even get into that for this conversation. We might have to have a separate one
Yeah.
about orbital racing. Interesting.
Mhm.
Well, so how do you kind of manage the balance between lower cost, standardized design, and reliability?
Yeah, no, it's a great question. So to achieve our affordability, there's a few things at play. We use domestic supply chains, we use vertical integration, and through standardization, we can reduce the amount of custom engineering effort. The term is typically NRE, non-recurring engineering effort, associated with going from one build to the next. And so that allows us to keep our engineering team very lean, staff up with technicians, and simply generate these platforms and put them on the shelf as true commercial items that are ready to be, flown at the earliest available launch opportunity, right? But another key thing we do is sourcing automotive-grade components. And this is one thing that it has been challenging is to challenge the price and the cost assumptions in this market right now. Simply because something is maybe designed for space or has flown to space before, vendors will put a 5 to 10x markup on the price of that product. And I think that's unacceptable. It's driving the prices up. It is locking out American innovators, and they're having to move elsewhere to be able to afford a single demo mission to get their technology mature. And so this is something we look across the board at our bill of materials, and we say, where can we optimize cost on a part-by-part basis? Swapping out space-grade components with commercial or automotive-grade alternatives. And the other thing that's really interesting that we've seen is I have customers coming to me and saying, we only need to fly for 6 months. In fact, one customer even said, I only want to fly for 2 weeks. I need to know that my algorithm or my reaction wheel or my product, I need to know it's going to work, right? And then I can begin scaling production, selling to corporates, selling to the government, right? But this unlocks this interesting use case of, well, I can just design this for a year in orbit, right? Because by the time we get to 12 months in orbit, the hardware and the software has already evolved by, eons on the ground. We see how fast the AI shift has been dramatically, tearing through this industry, upending entire businesses in the software space, and how we can leverage those technologies to greatly accelerate the fielding of space capability. So taking all of that together through our vertical integration approach, our optimization of the individual components, challenging cost assumptions, and long-term strategic partnerships, we can lower these costs to our end consumers and even eliminate those pesky tariffs that some American innovators are now paying when they're importing European buses.
Ah, yes. Where are you in the development process? I know you mentioned you have a flight scheduled for later this year, I think. When will you start flying, or have you already started flying?
Yeah, it's a great question. We like to get out of paper and into building real hardware as soon as we can at Blackwing. My team, we're all builders and we iterate the hardware extremely rapidly. And so we've only been operating about 7 months. We're going to be launching our first satellite called Baby Bird with 3 commercial payloads on board. Again, a full scale model of it right here. Thanks to our partners over at CEOPS for helping manifest us onto a SpaceX transporter mission. So within 12 months of starting the company, we have designed and we're about to integrate the satellite starting next week, which is extremely exciting. And we're going to deliver that for integration and have flight heritage by the end of the year. And I think that's a message the industry needs to hear. You don't need hundreds and hundreds of millions of dollars and hundreds of people and 100,000 square foot manufacturing facility to fly a space mission. You can do it with 5 people and a shoestring budget and an amazing capability that scales really, really well. And I think the amazing time to be building in space. Access to space has never been easier, especially in these small form factors. We are not blocked by launch way that the larger satellites are.
Right. Vision to actually have these sort
Sitting
of
there ready for flight integration. And this is something the industry needs. If you're a startup, you can't wait 12 to 18 months for a build. Your entire runway could be less than that, right? And we want to be able to take it off the shelf and be the first company to deliver a satellite in 2 weeks. And we can think of as well the amazing government applications as well. Tactically responsive space is a very important theme right now. How do we deploy capability for our government partners as rapidly as possible? We do it with commercial mass manufactured satellites that are awaiting integration with government payloads that comply with our specification. And if we can do that well, we can not only launch within 24 hours from call up, we might even be able to build the satellite and launch it within 24 hours. And wouldn't that be a next generation capability to secure this nation's future?
Indeed. Wow, that would definitely be a dramatic shift. Well, Paul, I want to thank you so much for making time to be here today. If someone wanted to learn more about Blackwing Space, what should they do?
So great. You can reach out on our website, blackwingspace.com. You can find us on LinkedIn. We're very active there. Or reach out to hello@blackwingspace.com as well. So a variety of ways to reach us. We'd love to hear from you. We love sharing more about what we're building and how we can help you deploy your payload to orbit as rapidly and as affordably as possible.
Excellent. Well, thank you so much again for being here today. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.